Enterprise computing is a rigid physical reality. It relies on massive, concrete facilities packed with tangible hardware, intense cooling, and intricate cabling. But the end user never sees that machinery. When we look at the top layers of this cloud service pyramid, like software as a service or function as a service, the experience is entirely seamless. The hardware is completely invisible. The cloud functions as an engineered illusion, a structured architectural framework designed to mask the complexity of thousands of physical servers behind a single, accessible API. To understand how that illusion actually functions, we have to map the specific technology that makes it possible, virtualization, and how it deliberately decouples digital capability from physical hardware. We are going to construct this architecture from the bare metal upwards. We'll analyze the actors who govern the ecosystem, the deployment models that dictate where data lives, and the service layers that define what you actually control. For an IT architect, mastering the cloud means cutting through the abstraction layer. You have to know exactly what is executing beneath the software to maintain strict security and control over an enterprise environment. This image captures the literal foundation of the cloud. Before any code executes, you need real facilities housing servers, memory, and networking gear. This architectural diagram formalizes that physical reality. The base layer represents tangible hardware, raw compute from CPUs, physical storage, and switches to move data. Directly above sits the resource abstraction layer, which intentionally breaks the one-to-one bond between software and the physical machine. Through specialized software like hypervisors and software-defined networking, a single physical server is sliced into multiple, completely isolated virtual machines and virtual subnets. By abstracting and pooling these resources together, providers create a massive, unified environment where capability can be allocated instantly. Bare metal hardware is rigid and finite. The virtualization layer is what officially creates the elastic computing environment that defines the cloud. Once this elastic stack is built, it's too complex for any single entity to manage end-to-end. It requires a federated ecosystem of highly specialized roles. This NIST diagram maps how these roles interact. At the center, the provider manages hardware and services. On the left, the consumer provisions resources. Below, the carrier ensures data transport. Externally, auditors assess compliance, while brokers aggregate services into a single access point. In enterprise deployments, systemic failures often stem from blurred boundaries of responsibility between these actors, where an essential security configuration falls through the cracks. Establishing who manages the stack naturally leads to the next architectural decision, determining exactly where that infrastructure is legally and physically isolated. Architects choose from 4 deployment models. Public cloud is economical for broad workloads. Private cloud gives exclusive hardware control for severe security demands. Community cloud is shared among consortiums with identical compliance needs. The hybrid cloud orchestrates a combination of these environments. Selecting the correct deployment model is the most foundational risk management decision an IT architect will make, long before a single line of code is written. While the deployment model dictates where the cloud lives, the service model defines how much of the technical stack the consumer actually has to manage. This pyramid breaks down the hierarchy of those cloud service models. The governing rule of this hierarchy is strict. Moving up the pyramid increases the level of abstraction. As abstraction goes up, your operational overhead goes down, but you sacrifice granular control over the underlying system. At the base is infrastructure as a service. Here, the consumer rents raw virtual machines and networks. You have maximum flexibility, but you retain full responsibility for patching the operating system, installing the middleware, and maintaining the runtime environment. Moving up to platform as a service, the provider takes over the operating system and the runtime. Developers no longer configure servers. They simply upload their code and focus entirely on business logic. Software as a service abstracts things even further. The provider handles the entire stack, delivering a finished application over the web. The consumer only manages user accounts and data access. At the very apex is function as a service. This is a purely event-driven architecture where code executes strictly in response to precise triggers, like an HTTP request or a file upload. Function as a service requires zero infrastructure management. It scales from 0 to thousands of instances instantly, billed strictly by the millisecond of execution. Choosing a service model buys operational velocity. The provider manages the heavy lifting below, freeing your engineering team to innovate at the top layers. A modern enterprise cloud strategy is never a single monolithic choice. It is a calculated matrix of decisions. A real-world solution maps the deployment matrix against the cloud service pyramid. It dictates exactly where your data legally resides and exactly which actor holds responsibility for the operating stack. As you engineer higher into the architectural abstraction, you intentionally trade deep infrastructure control for rapid, scalable innovation. Understanding the mechanics of these layered boundaries is how architects prevent catastrophic misconfigurations. It ensures that the right entity is managing the right layer in the right environment at all times. But these architectures remain static blueprints until they are activated. To see how these virtual models are actually propelled into action, we have to look at the specific cloud-enabling technology